This is HRW913P001. A mass m is split into two parts, m and big M minus little m, which are then separated by a certain distance. What ratio of little m to big M maximizes the magnitude of the gravitational force between the parts? Okay, first thing when you look at this, you're probably thinking, that's how in the world would you ever do that? So first clue here is this word maximizes. Whenever you see that word maximizes, it probably means we're going to do an optimization problem. You might have done that in calculus already, but I'll show you how. So first off, we're going to have two masses. Okay, so we've got our little m, and we've got our big M minus little m. Notice, oh yeah, sorry, and then their distance r apart. R. Okay. Now, it says what ratio of little m to m, big M, sorry, maximizes the magnitude of the gravitational force. We're not going to move r, so these are fixed in place. We can't change large m. Basically, the only thing we can change is little m. Okay, how much of the mass is going to be split off over here to the left, and how much is left behind depends on our quantity for little m. So that's really our only variable here. Everything else is constants. So I need to write an equation for the thing I want to maximize in terms of little m as a variable. I want to maximize the magnitude of the gravitational force between the parts. So the equation for gravitational force between two masses is big G, m times m. So one of the m's is little m, one of the m's is big M minus little m, and then everything is divided by r squared. Alrighty, so I want to maximize this. The way that you maximize something is you get it as an equation, and then you take the derivative of it and set that derivative equal to 0, so that, and I'm gonna just kind of sketch a function. This is not the function we're dealing with, but I'm just gonna sketch a function. Let's say this is the quantity you were trying to optimize. Okay, we're trying to optimize force of gravity, and let's just say that our equation ended up being something like this. If we graphed it, it would look like this. The minimum is right down here at the bottom, like right there. I know that at that point where basically you stop going down and start going up, the slope should be 0. Okay, the slope should be 0 right there. So what I do by taking this and taking its derivative is, remember that the derivative of something equals its slope. So if I can find the derivative of this and set the derivative equal to 0, I'm saying that the value for whatever it is here, so I'm going to do m, the value right here, this value is the value at which the force will be the lowest. So I need to get this in terms of little m, and then I need to take the derivative. I'm going to go full screen here. Okay, so if I multiply this out, I get that the force of gravity is equal to G. See, I've got, oh, I'm going to leave G outside. Okay, I get little m big M, okay, minus m squared is what I get. And that's all over r squared. Okay. Now I need to take the derivative. Now all this stuff out here, those are constants. So I'm just going to pull it out. Let's see. Actually, no, I'm not going to pull out. I'm going to do, okay, so if I pull this up, or, sorry, put this all together. Sorry, it's kind of late. Okay, over r squared. I'm going to separate those out. So really what I've got is G, and I'm going to put this at the end since it's my variable, really, over r squared minus G over r squared m squared. Little m, sorry. Okay, so now I take the derivative. The derivative is, well, remember m is my variable, actually, so I should be writing it like that. I should be writing it as like that. Okay, So right here we basically have a linear term. That means when I get the derivative, I just end up with a constant. And then minus, well, I've got this exponent here, so I'm going to bring that down in front. Okay. And that leaves me, and then I subtract 1, that leaves me with m to the first, so I'm going to leave it alone. Now, I set that derivative equal to 0, so really 0 equals g big M over r squared minus 2g over r squared times little m. Now, what I want is the ratio, go look at this again, I want the ratio m over big M. So I basically need to solve this equation so I end up with little m over big M on the left-hand side equals something. Okay, so, and that will tell me what that something is. Sorry, I hit the pause button instead of the full screen button. Whoops. Okay, I want to get the two m's divided, so I got to get them on opposite sides first. So if I move this over here, I get 2g over r squared times m, little m, sorry, equals g big M over r squared. Notice I have an r squared on both sides, so those are going to go away. I also have a g on both sides. So what I really have is 2 little m's equals 1 big M. So the ratio of little m to big M would end up being, if I divide both sides by big M and then divide both sides by 2, I end up with that little m over big M should equal 1 over 2. So the ratio is 1/2 or 0.5. And that is exactly what the answer is.